All right, this is our Module 1 Homework 2 notes. So we are going to be talking about inequalities. So inequalities are less than and greater than. So it's kind of, I remember going back, thinking about the alligator eats the bigger one. So our less than sign, the alligator is going to eat the bigger one. And our greater than sign is like the alligator's mouth. Again, the mouth eats the bigger one. So for inequalities, we have less than, we have greater than, and then we also have our or equals to. So remember the less than with the line underneath it means less than or equals to. Similarly, the greater than with a line underneath it means greater than or equal to. So those are different options for our inequality symbols. So we mentioned or equals to. So when we said or equals to, so whenever it's saying, let's just start from the beginning. Okay, so if we have x, for example, is less than 2. It's saying x can be any number less than 2. So it can be 0, it could be -1, it could be -100, it could be 1.9999999. It just has to be less than 2, not equal to 2. So that 2 is not included. If we have x is less than or equals to 2, that means x can be 2. It can also be everything less than 2. So 2, 1.99999, 0, -1, everything less than 2. And this time it's including 2. Because 2 could also be an answer because x can be less than or equals to 2. So this is just going to be less than 2. And this would be less than or equal to less than or equal to 2. Just less than 2 and less than or equal to 2. So because this 2 is included in our answer, x can be 2 and everything less than it, that's what we are included. So included, whenever we show our answer could be included, we're going to use our or equals to, so less than or equals to, greater than or equals to, and then we're going to use our square brackets. Square brackets, we'll talk about this in a second. And then whenever it's not included, just like this one up here, 2 is not included in the answer, only everything less than 2. We just have our less thans and our greater thans, and for that we're going to use our parentheses. So if we have an answer, can infinity or negative infinity ever be included? Well, could we ever reach infinity or negative infinity? No. So because we can never reach infinity or negative infinity, it's never going to be included. So no. Let me write something up here to kind of, I was thinking about it to kind of help explain this better. So, so less than 2 is just going to say everything less than 2. So everything less than 2. Whenever 2 is included, it's saying 2 and everything less. So less than or equal to 2. So in other words, 2 and everything less than 2. That 2 is also included. Okay. All right, so is infinity or negative infinity included? Remember that this little symbol means infinity, means it goes on forever. So no, we're never going to include infinity or negative infinity because we can never reach infinity or negative infinity. It goes on forever, we can never reach it. So whenever we're talking about is it included or not, infinity and negative infinity are never included. So because they're not included, we're going to use our less than, equal than, I'm sorry, less than, greater than, and our parentheses, not the equal than. So let me write that as a little note. So always use less than, greater than, parentheses for infinity and negative infinity. So always use our not included for infinity and negative infinity. All right, so that's parentheses versus brackets. So parentheses are our normal parentheses that we use to group stuff with. And then our brackets are the same concept, but we use the square ones to show that it's included. We're talking about this more later. We're just kind of talking about our different symbols right now. So notation is just another way of saying how we name things. So our notation is our naming. Our notation is our naming. So we have two different ways of naming or notating things. We have set builder notation and we have interval notation. Interval notation is when we're going to use the most, but let's talk about set builder. So for set builder notation, we have a template. Here's our template. It's going to get blurry for 1 second because I feel like it's not focused good. So our template says with a curly bracket, the set of x such that blank, whatever our answer is. So for example, to fill in the template, the set of x such that x is less than 2. And that's how we would formally write our answer using set builder notation. So the curly brackets mean the set, this, the set of, and then this variables x, so the set of x. If our answer used z, we would say the set of z such that z is less than 2. But the set of x, this vertical bar means such that, and then blah, 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 whatever your answer is. For example, we have x is less than 2. So for set builder notation, just a way of formally writing our answer, and we use this template, and then you just fill in the blank with what your answer is. For interval notation, this is the one that we use more. And it's saying it's an interval. So an interval is from one number to another number. We're talking about our endpoints. So for our endpoints, we can either use parentheses or brackets, whether they're both parentheses, one of them's a parenthesis, one of them's a bracket, or both square brackets. Talking about our parentheses and square brackets up here. So notice parentheses means that our endpoint is not included, and square brackets means that our endpoint is included. So I know you're probably like, what is she talking about? We'll get there, I promise. So it's very important that the numbers must be in order from least to greatest. So a lot of times we use a number line to help us show it, to show what is least to greatest. We're going to use the furthest left number and the furthest right number, but it's super important that we put our answers in order from least to greatest, from left to right, because we read from left to right. All right, let's kind of put this together and see about what we're actually talking about here. It says, for example, graph the inequality and then give interval notation. And then this is for your homework. For entry tip, use 2 O's as an octopus, so the letter O for the infinity symbol and for negative infinity. So that's how you put it into your homework. Just use 2 letter O's and it will make the infinity symbol for you. So x is greater than 2. This is what we're talking about. X is greater than 2. It gives us a number line. We want to graph the inequality on our number line. And then once we have the graph, we can use our graph to write in interval notation. So it's saying x is greater than 2. So we're talking about the number 2 and everything greater. So everything greater would be everything to the right. Notice our number line goes from negative infinity, which is over here is negative numbers, and it goes on forever towards positive infinity with our positive numbers over here. So we're talking about 2 and everything greater, everything on the right-hand side from 2 on. Now, speaking of 2, is 2 included in the answer or is 2 not included? So looking at our symbol, we have just greater than. So going up here, greater than means that it's everything less than 2, not including 2. So 2 is not included. So our endpoint is not included. So let me write that as a little note here. So 2 is not included. And what that means, not included, it means for our answer, for x, x can be everything greater than 2, just not 2. So it could be 3, it could be 4, it could be 5, it could be 2.00001. It just cannot be exactly 2. So 2 is not included. So because it's not included, so we're going to use parentheses. This up here, remember brackets are parentheses. It's not included, so we're going to use parentheses. I have a lot of students who, whenever they learn this, they use open and closed circles. So if you did, going back to kind of relate that, parentheses were the same as open circles. To show that that endpoint was not included, we did an open circle. So sometimes they drew an open circle right here at 2. So whether you did an open circle to show that 2 is not included, or whether you did a parenthesis. Either way, that would be your answer. So we graphed it. Let's talk about writing our answer in interval notation. Let me just see one thing real quick. Yeah, on the homework, it does the option for open circle or closed circle. So you would choose an open circle because it's not included. And then you would put an open circle at 2 and then use your click on everything on the right-hand side, everything that's greater than 2. All right, so that's great. So now write our answer in interval notation. We graphed it, interval notation. So reading a graph from left to right, the left side of my graph starts at 2 with a parenthesis, it's not included, so parenthesis at 2, and then our graph goes on forever, nothing stopping it towards positive infinity. We said we can never reach positive infinity, it's never included, so we're always going to use parentheses for those, so to close it off. So we're saying our answer can be from 2, not including 2, all the way to infinity. We can never reach infinity, so we can never include infinity. So here's our answer, parenthesis 2, comma, infinity parenthesis, and this is just grouping it together. So here's our endpoint. So this parenthesis goes with 2, this parenthesis goes with infinity. Let's do some more examples. So graph the inequality and then give interval notation. So we have -2 is greater than or equal to x. Now this is kind of weird, the way they wrote the x second. So let's flip this around. So we have x and -2. Notice the mouth is opening up to -2. So whenever I flip this around, make sure to flip it so that way the mouth stays opening to -2. So this looks better. So now it's saying x is less than or equal to -2. So here's our number line. Remember, our number line goes from negative infinity on the left all the way on forever towards positive infinity to the right. We're talking about -2, and we're saying x is less than that. So everything less, everything on the left-hand side. Let me use my marker. So going on forever towards negative infinity. Notice whenever x comes first, like how I rewrote it, the inequality symbol, the less than or equal to symbol, is kind of like pointing to the left, just like my arrow here points to the left. So that's kind of a good little trick. So notice this time it says or equals to. So because or equals to, it's saying, okay, so -2 is included. So it's everything less than -2, including -2. So because it's included, let's move it up into this other space here. So we're going to use, going up here, it's included, so we're going to use square brackets. And then instead of open circles, we're going to use a closed circle to show that it is included. All right, so -2 is included. So we're going to show that on our graph by doing a closed circle. So again, on the homework, you choose a closed circle, plot it at -2, and then use your arrow to go everything to the left. It's really self-explanatory once you get on there, but email me if you have any questions. Or you'll see in some textbooks that it will do the square brackets right here on the graph. So square bracket, and then going on further to the right towards -infinity. Same thing. All right, so now that we have our graph, let's write our answer using interval notation. So reading our graph from left to right, our graph goes on forever to the left, nothing's stopping it. So it's going on forever towards -infinity. We can never reach -infinity, so -infinity is never included, so we're always going to use parentheses. So a parenthesis for that -infinity. Remember that this symbol goes with this number, comma. So now we're talking about the right-hand side of the graph. So the right-hand side of the graph is at -2. It stops at -2. It's included, so we're going to use a closed circle or a square bracket. So again, this symbol goes with the -infinity. This symbol goes with the -2. So there's our interval notation. A parenthesis from -infinity, comma, to -2 with a square bracket. Just a little side note here. So for set builder notation, just a little side note. So if it asks us for set builder notation, we would have our curly brackets. So the set of x, because x is the variable we're using, such that, here's our template, the set of x such that our answer is x is less than or equal to -2. And then closing out our set with another curly bracket. So the set of x such that x is less than or equal to -2. Those are curly brackets. It's supposed to look like these. I'm just not very good at drawing. All right. So let's look at some more examples on the next page. So it says graph each inequality and then give interval notation. So same thing, but now I have what's called a compound inequality. So I have what's called a compound inequality. I have 1 is less than x is less than or equal to 2. So a compound inequality has two inequality symbols. So we have two boundaries. A compound inequality symbols has two inequality. Compound inequality has two, and I forgot the rest of the word. Inequality symbols. There we go. Compound inequality has two inequality symbols. All right, so I have 1 is less than x. So this less than symbol goes with the 1. And then x is less than or equal to 2. So this less than or equal to symbol goes with the 2. So because it's less than, we know that 1 is not included. It's just less than, so we know it's not included. So we're going to use parentheses. And open circles. This less than or equal to symbol goes with the 2. So less than or equal to means that it is included. So we're going to use square brackets. And close circles. I'm going to move this so that way you can really differentiate which one goes where. So use parentheses. So not included, so we're going to use parentheses and open circles. This one is included, so we're going to use square brackets and circles. Again, I knew that because of the symbol. The symbol is less than means that it's not included. The symbol is greater than or equal to, that means it is included. All right, so the left-hand side of my graph starts at 1, and 1 is not included, so we're going to use an open circle at 1. The right hand of my equation stops at 2. 2 is included, so we're going to use a closed circle. Notice x is sandwiched between 1 and 2, so my graph is literally going to be between 1 and 2. So just connecting the dots. Open circle at 1 because 1's not included, it's just less than. Closed circle at 2 because 2 is included because it's less than or equals to. The or equals to tells me it can't equal to, so that 2 is included in our answer. If you want to go to the parentheses and square brackets thing, open circle is a parenthesis, 1's not included. 2 is a square bracket because it is included, and everything in between, just to stay consistent. So now that we graphed it, let's write our answer using interval notation. So the left side of our graph is at 1. Open circle, so that means parenthesis, it's not included. Really want to make sure that's a parenthesis and not a square bracket. So parenthesis at 1. And the right side of our graph is stopping at 2. 2 is included, so that's going to be a square bracket. So it's saying our answer, x can be anything between 1 and 2. It can't be 1, not including 1, but it can be at 2. It does include 2. All right, so this course is all about taking things and adding on to it. So we talked about inequalities. So adding on the inequalities to what we did on the previous section of solving equations. So now we're going to solve inequalities. So solve the inequality, graph the solution, and state the solution in interval notation. So we have -4 times -x plus 5 plus 16 is greater than 2 times 3x minus 5 plus 4. Alrighty. So just like we were solving a normal equation where it has equal to instead of greater than, we have parentheses, let's distribute. Let's distribute. So -4 is outside this first set of parentheses, so we're going to distribute or multiply that -4 to everything inside the parentheses. Likewise, this +2 is outside the second set of parentheses, so we are going to distribute or multiply +2 to everything inside the second set of parentheses. Let's go for it. So distributing -4 times -x is +4x. -4 times +5 is -20. That's all that was in parentheses, so all we're distributing. We have plus 16 is greater than, let's distribute the 2, so 2 times 3x would give us 6x. 2 times -5 would give us -10. That's all that's in parentheses, so that's all we're distributing, and then that plus 4x is on the outside. All right, so we have 4x minus 20 plus 16 is greater than 6x minus 10 plus 4. Let's combine some like terms to make stuff look a little bit better. So combine like terms. So we have -20 plus 16. Those are just numbers. Notice they're on the same side of the equation. So don't do the opposite. They're on the same side of the equation. So just combine them together. So 4x, -20 plus 16 will give us -4. So 4x minus 4 is on the left-hand side. Keeping our same greater than symbol. On the right-hand side of the equation, we have 6x minus 10 plus 4. Combining those like terms, let's combine 6x plus 4x. So 6x plus 4x will leave us with 10x. So we have 10x minus 10. So looking better, looking better. So we have 4x minus 4 is greater than 10x minus 10. So now that we have our like terms combined on each side, let's get our x's together. Let's move this 10x to the other side of the equation with the 4x. Because we're moving to the other side of the equation, now is when you do the opposite. So the opposite of positive 10x would be negative 10x. So we can subtract 10x from both sides of the equation. That way 10x minus 10x cancels out and goes to 0. We're left over with 4x minus 10x, which would be negative 6x minus 4 is greater than 10x minus 10x, which goes to 0 and cancels out. You're left over with negative 10. So 6x minus 4 is greater than negative 10. All right, so getting, again, x by itself, let's get rid of this minus 4. Let's get rid of our adding and subtracting. So let's get rid of that minus 4. Let's move that minus 4 to the other side. Because we're moving to the other side, let's do the opposite. The opposite of minus 4 is adding 4. So let's add 4 to both sides of the equation. That way negative 4 plus 4 cancels out. We are left over with negative 6x is greater than negative 10 plus 4. Negative 10 plus 4 would give us negative 6. Use your calculator if you need to. Don't make a little mistake like that. Getting x by itself, we're almost done. It's negative 6 times x. So let's do the opposite to move the negative 6 to the other side of the equation. The opposite of negative 6 times x would be to divide both sides by negative 6. So negative 6 divided by 6 cancels out. We're left over with 1x, or just x. On the other side, we have negative 6 divided by negative 6, which is 1. Notice I didn't write the symbol yet. Super important. Super important. Let me grab a color that will stand out. So we divided by a negative. So we're going from negative sides and we divided by a negative. So these negatives became positive. So we were going this way, and now we're flipping. We're going in the negative direction. We're going in the negative direction, and now we flipped it, and our negatives became positive. So now we're flipping and going in the positive direction. So we were going to the negative direction, then we flipped it, now we're going to positive. So because of that flip, we need to flip our sign. So flip our sign when we multiply or divide by a negative number. So only flip it whenever you're multiplying or dividing by a negative number. Here we divided by negative 6, so flip the sign. So instead of greater than, we are going to be now less than. So here's our inequality. X is less than 1. Notice it's less than, so that means open circles, not included. Not included. So we're going to use parentheses to show that it's not included, and open circles. All right, so we're talking about positive 1. So at positive 1, we're going to use an open circle because it's not included. And we're saying x is less than. So everything less than, everything to the right. Remember, our graph goes on forever towards negative infinity on the left and towards positive infinity on the right. So our graph is going on forever towards negative infinity. So writing our answer, we graphed it. Last thing is write our answer in interval notation. Reading our graph from left to right, our graph really helps us write our answer in interval notation. So reading our graph from left to right, the left side of my graph goes on forever towards negative infinity. We can never reach negative infinity, so we're going to use a parenthesis. And then our graph on the right-hand side stops at positive 1, open circle, so open parenthesis. So there's our answer in interval notation. Parenthesis from negative infinity, comma, positive 1, closing out with a parenthesis. All right, last one for this page. So solve the following inequality, write your solution as an inequality. So just leave it as an inequality. So we're putting together inequalities, solving equations, and then now fractions. So it says 6 over 2 plus b is less than 21 over 12. We talked about this before. There's fractions galore. So let's go ahead and get rid of these fractions. Fractions mean divide. So in order to get rid of the fractions, we can multiply by the LCD. Remember that? Multiply by the LCD, going back to Module 1, Homework 1. So multiply by the LCD to get rid of fractions. So our denominators here are 2 and 12. So I can make both of these fractions into 12. This one's already 12. If I need to make this one into 12, I can just multiply the top and the bottom by 6. I don't have to do that because I'm going to get rid of them. I'm just going to use that LCD. So we're going to multiply everything by our LCD of 12. Remember, we're multiplying fractions. So top times top, bottom times bottom. So if you want to write it as 12 over 1, go for it. Because 12 divided by 1 is still 12. So let's distribute that to every single term on both sides of the equation. Again, we're multiplying fractions, so top times top, bottom times bottom. So 12 over 1 times 6 over 2, top times top, 12 times 6 would give us 36. Sorry, 12 times 6 would give us 72. Over 1 times 2 would give us 2. Plus 12 times b, which is just 12b. I don't need to write it as a fraction. So it's just 12b over 1. Oops. Is less than top times top, bottom times bottom. 12 over 1 times 21 over 12. So 12 times 21, which would give us 252. Use your calculator. All over bottom times bottom, 1 times 12, which is 12. So 7 over 2 plus 12b is less than 252 over 12. Remember, so now whenever we simplify, our fraction should go away. Whenever we simplify, our fraction should go away. So 72 divided by 2 should give us 36. That fraction went away. Plus 12b is less than 252 divided by 12. 252 divided by 12 would give us 21. All right, so we have 36 plus 12b is less than 21. Now it's like a normal equation. Let's solve it. You want that little line to show that we have two sides of the equation. Let's get rid of our adding and subtracting. Let's move this adding 36 to the other side. So the opposite of adding 36 would be to subtract 36 from both sides. That way 36 minus 36 cancels out. We're left with 12b is less than 21 minus 36. 21 minus 36 would give us negative 15. Almost done. So 12 times b is less than negative 15. So 12 times b, we're trying to get b by itself. It's being multiplied by 12. So the opposite would be to divide by 12. The way 12 divided by 12 goes to 1. We're left with 1b. It cancels out. 1b is just b. Is less than negative 15 over 12. So we got b by itself. We always want to simplify our fractions. So here I have negative 15 divided by 12. I can simplify this because 3 goes into both negative 15 and 12 evenly. So let's simplify our fraction. Don't forget to do that. Let's divide the top and the bottom by 3. So we're left with b is less than negative 15 divided by 3 is negative 5. Over 12 divided by 3 is 4. So now 5 over 4, I know there's nothing that 5 and 4 have in common, so that's as simple as it gets. It says write it as an inequality, so I can leave it just like this. Remember, going back to our fraction review page, that so we can leave that negative on the top, on the bottom, or out front. Top and the bottom or out front. So I can put that negative out front, and boom, there's my answer. B is less than negative 5/4. Done. All right, last page for this section. 2 more examples. Write the following in interval notation. Negative 14 is less than negative 3 times x minus 11 is less than or equal to negative 8. So now we're solving a compound inequality. So now, instead of us having one inequality, so one thing that's separating our two sides, now we have 2 inequalities. So now if I separate my inequality symbols, if you notice, I have 3 sides of the equation. I have the left side of the equation, I have the middle, and I have the right side, but it's still the same thing. Just remember, what you do to one side, you have to do to all sides. So let's try to get x by itself. If I have negative 3 times x minus 11, let's go ahead and let's distribute that negative 3. So I have negative 14 staying the same, our less than sign staying the same. Negative 3 times x would give us negative 3x. Negative 3 times negative 11 would give us negative 33, less than or equal to negative 8. Great. All right, so now if it helps you, just get rid of those two things and just focus on the middle. Negative 3x minus 33. On a normal equation, how would I get x by itself? Let's get rid of our adding and subtracting. Let's get rid of that minus 33. The opposite of minus 33 is to add 33. That way negative 33 plus 33 cancels out. What you do to one side, you have to do to all sides. So let's add 33 to all sides of our equation. We are left over with negative 14 plus 33, which would give us negative 47, is less than negative 3x is less than or equal to, our 33 is canceled out, negative 8 plus 33, negative 8 plus 33 would give us negative 41. I messed up. I'm sorry. We'll fix it right now. So where I messed up, and bonus points if you can see it, negative 3 times negative 11 give us positive 33. So that's positive 33. Negative 3 times negative 11 should give us positive 33. So instead of adding 33 to all sides, we needed to subtract 33 from all sides. I'm sorry, my bad. So subtract 33. So now they cancel out. All right, so that's better. So negative 14 minus 33 would give us negative 47. And then our 33 is canceled. We're left with negative 3x. Negative is less than or equal to negative 8 minus 33, which would give us negative 41. There we go. I knew something was off and I couldn't see it at first. I was just making sure you're paying attention, keeping you on your toes. All right, last step. Negative 47 less than negative 3x less than or equal to negative 1. Again, I want to get x by itself. What's happening to x? It's being multiplied by negative 3. The opposite of multiplying by negative 3 is to divide by negative 3. So let's divide all sides by negative 3. What you do to one side, you have to do to all sides. So all three sides get divided by negative 3. That way my negative 3 divided by negative 3 cancels out. We're left over with negative 47 divided by negative 3. So likewise, my negatives cancel out here, and we're just left with 47 over 3. There's nothing that 47 and 3 have in common, so just leave it just like that. Pause on the symbols for a second. Our negative 3's cancel, we're left with x. And then we have negative 41 divided by negative 3. Again, our negatives cancel out, so we're left over with positive 41 over 3. Positive 41 over 3. 41 over 3 have nothing in common, so we can't simplify it further. So notice I left out my signs. We divided by negative 3. What happens whenever you multiply or divide by a negative number? Flip the sign. So we have to flip our sign. So instead of being less than, it'll now be greater than. Instead of being less than or equal to, it'll now be greater than or equal to. Notice that our equation went from negatives to positives, so that's why we have to flip it. So let's write that. Remember to flip the sign. When we multiply or divide by a negative number. So we divided by negative 3, so we had to flip the signs. So you always want to put it from least to greatest. If you put 47 over 3 in your calculator, and if you put 41 over 3 in your calculator, 41 over 3 is smaller, so we have to put this 41 over 3 first. Whenever you have compound inequalities, by the way, you always use less than or less than or equal to. So this looks weird to me. So let's flip it around so it looks better. So we have 41 over 3, less than or equal to, and then x, and then we have 47 over 3. So for 41 over 3, the x is greater, so I need to flip the sign to make sure that the x stays greater. The mouth is opening up to x here. The mouth needs to stay opening up to x. So now with my 47 over 3, we had greater than. The mouth is opening up to 47 over 3. So the mouth has to stay opening up to 47 over 3. So now we'll flip it and have our less than. So here is our answer, but it says write the following in interval notation. So I'm going to draw a quick number line that will help us see our answer in interval notation. Remember our interval notation on our number line goes from -infinity to +infinity. The left side of my graph starting at 41 over 3. Less than or equals to, so closed circle. The right side of my graph is stopping at 47 over 3. Just less than, so open circle. X is sandwiched between, so my graph is going to be everything between those two. So here's my graph. We can see it a little better. And this graph will help us write our answer using interval notation. So going from left to right, the left side of my graph's at 41 over 3. Closed circle, because it's or equals to, so it's included, so that means square bracket. The right side of my graph stopping at 47 over 3. Open circle, because it's just less than, so we're going to use a parenthesis. And that is our final answer. I get this question, so I'm just going to go ahead and answer it. If it doesn't ask you to specifically graph it, and you can go from the interval to interval notation, that's okay. I just want the answer. A lot of times, even me, whenever I'm doing a problem like this, compound inequalities are a little bit easier because you can see the endpoints, but whenever you have just a regular inequality, the graph is super helpful. So take 2 seconds and then make sure that you get it right. So do you have to do the number line always? No, but it's really helpful. So our final answer is a square bracket from 41 over 3 to 47 over 3 with a closed, with a parenthesis. Last one. So it says a student has a score of 88.25, 86.25, and 93 on his first 3 tests. He needs an average of at least 90 to earn a grade of A. What is the minimum score the student needs on the 4th test to ensure an A? All right, so let's see. So he needs an average of 90. So average means adding all up and dividing how many tests. So his first test was 88.25, plus his next test was 86.25, plus his next test was 93, first 3 tests. How much is he need on his 4th test? I don't know how much he's going to get on his 4th test. That's what we're looking for. So let's call that X. So if we add up all of his test scores, divided by the number of tests to give our average. Remember, the average means add and then divide by number of tests. So we have 1, 2, 3, 4 tests. So we're going to add it up and divide by 4. This will give us his average. And it says he needs to earn at least a 90. So this grade, this average needs to be greater than or equal to 90. Because if you get to 90, that's okay. It'll still be an A. So we can use or equals to. But this average has to be greater than or equal to 90 to give us a 90 or above to give him an A. So here's our equation. Let's solve our equation. Let's combine some like terms first because we got a bunch of stuff going on. So combine like terms. Let's add up the 88.25 plus the 86.25 plus the 93. I don't know where. Oh, I see it. So adding up and combining like terms. So 88.25 plus 86.25 plus 93 would give us 267.5 plus our x all over our 4 has to be greater than or equal to 90. All right, so let's solve this equation. We don't like fractions, so let's get rid of fractions. So we're dividing by 4, and this whole thing is being divided by 4. So we're from the outside in. So on the outside is this divided by 4. So let's get rid of that dividing by 4. The opposite of dividing by 4 is multiplying by 4. So that way our 4's cancel out. And we are left over with 267.5 plus our x has to be greater than or equal to 90 times 4, which is 360. All right, last but not least, getting x by itself. I had 267.5 plus x, so let's subtract 267.5 from both sides. That way those 267.5 minus 267.5 cancel each other out, goes to 0. You're left over with x is greater than or equal to 360 minus 267.5. And that will say 92.5. That will say x has to be greater than or equal to 92.5. So the student has to get at least a 92.5 on his last test to get an A in the class. He has to get a 92.5 or better to get an A in the class, to get a 90, at least a 90. There we go. So what's the minimum score the student needs? Just a 92.5. That's the minimum score he needs. Alrighty. And that is all of Module 1 Homework 2 notes. Thank you for watching. Now make sure to go and complete Module 1 Homework 2 homework assignment, and we'll move on to the next notes section. If you have any questions, please email me. If not, thank you for watching.